Okay, so we're given a bunch of different ionic compounds here, and we have to write the formula. Well, first of all, how do I know it's ionic? Let's look at number one, or letter A rather. It gives us potassium and iodine. Potassium is K, iodine is I. And you got to know that it's ionic before you can even start. And the way that I know it's ionic is because potassium is a metal and iodine is a nonmetal. So that's how you know that you're dealing with an ionic compound as opposed to a covalent compound. Okay, so now that I know it's an ionic compound, I can get to work here. I know it's going to have the K in it and then the I in it. And I got to figure out the oxidation numbers for each element. And the oxidation number, it's a new word, but it's something that you already know how to do because we did it when we talked about ions. The oxidation number is just the charge that the ion would form. So for example, let's start with potassium here. The oxidation number for potassium, you got to look over at your periodic table. Potassium is right here. And it's in group 1, which means that in order to be happy, it's going to lose one electron. When you lose one electron, you become positive 1. So potassium is going to be positive 1. Next, let's do iodine. Iodine is over here, and it is in group 7, which means in order to be happy, it's going to gain one electron. If you gain one electron, you become negative 1. So over here, I'm going to put a negative 1. All ionic compounds are going to be neutral, which means they're going to have no charge, which means the charge needs to add up to 0. So here we have a positive 1 and a negative 1. That adds up to 0. So it's just going to be Ki. Negative 1, positive 1, adds up to 0. That's your final answer right there, Ki. You're all set. Let's take a look at letter B. It says magnesium and chlorine. Magnesium, oops, that should be uppercase. Magnesium is Mg. Chlorine looks like this. I know it's ionic because it's a metal and a nonmetal. Next, I need to figure out the oxidation numbers of each element. Let's find magnesium. See if you can find it yourself. Magnesium is over here. It's in group 2. That means that it's going to lose 2 electrons. In order to be happy, if you lose 2, then your charge is going to be positive 2. So over here, I'll add a positive 2. How about chlorine? See if you can find chlorine. Chlorine's over here. It's in group 7, which means it's going to gain 1 electron in order to be happy. It's going to gain 1. That means the charge is going to be negative 1. So now we have an issue, because if you just add these two together, it's not going to equal 0, is it? So you got to figure out a way to make it 0. What if I just take one of these magnesiums and then 2 of these chlorines? If I take 2 of these chlorines, then the charge will be negative 2, and then it'll add up to 0. So that's what I'll do. I'll do MgCl2. And now it adds up. So there's a trick. You don't actually have to do all this thinking in your head every time. You can just use the crisscross method. The oxidation number of this first element is going to be the subscript of the second one. The oxidation number of the second element is going to be the subscript of the first one. See how that happens? So that's a little trick you can use to make sure that you don't screw it up. Let's do another one, letter C here. It's sodium and sulfur. Sodium is Na, sulfur is S. We got to take a look at the oxidation numbers. See if you can find sodium. It's right there. It's in group 1, which means it's going to lose 1 electron, which means the charge is going to be positive 1. So I'll add a little positive 1 up here. Let's go take a look at sulfur. See if you can find sulfur. Sulfur's over here. It's in group 6, which means it's going to gain 2 electrons. When you gain 2, you become negative 2. So let's go back over here. Let's add a negative 2. Okay, so now we have an issue. If we just add these two together, it will not add up to 0, but you got to make it add up to 0. So if I take this one and do 2 of them, and then take this one, then they'll add up to 0. So we can say Na2S. And if you forget how to do that, if you don't want to mess it up, then you can just use a crisscross method. The oxidation number of the second one is going to be the subscript of the first one. The oxidation number of the first one is going to be the subscript of the second one. If there's a 1, we don't write it. And so that's how you do it. That's the answer for letter C. Let's skip ahead. There's two more for number 1. I'll let you do that yourself. Let's go ahead to number 2, where we have to name them. Name the ionic binary compounds, it says. So for letter A, for example, we have AgCl. You got to look up in your book and see what the actual names are if you don't know. Ag is silver. Cl is chlorine. But that's not how you write it. The rule is you write out the two elements except you change the end of the nonmetal to ide. IDE. That's it. That's all you do. So the answer would be silver chloride. That's how you write the name for that. Let's do another one. Letter B is zinc and oxygen. ZNO. You write the name of the metal, zinc, and then you write the name of the nonmetal, but instead of writing oxygen, I'm going to write oxide, and there we have it. You want to do one more? Let's do one more. You got a calcium, and then we got some bromine in there. The rule is you write the name of the metal, calcium, and then the nonmetal, but instead of writing bromine, I'm going to write bromide. And that's it. I hope that this was helpful.